This is the first of two videos in which I'm going to be reviewing how to factor polynomials. It's looking back on something that you would have learned in Pre-Calc 10. You might be watching this video as part of Chapter 4 because that's the first time in Pre-Calc 11 that we do factoring. It's also going to be useful really throughout the rest of the course, but especially in Chapter 6. If you want a little bit more detail on this, go back and look at the Foundations in Pre-Calc 10 videos. That's going to be the polynomials chapter, where there will be a lot more of this, where it'll be broken down more. So I'm going to be going pretty quickly through this since it is just supposed to act as a review. So, factoring. There's going to be a few different kinds of factoring that we need to look at. The first one is common factors. So, remember, a common factor, or even just a factor in general, is something that divides into something. So a common factor is going to be that something that divides into multiple things. And so when we're dealing with polynomials, we're really looking for something that divides into each term in our polynomial. That factor might be a number, a variable, it might be both, could even be more complicated than that. So starting with some basics. If we wanted to factor the binomial 3x plus 12. So when we're dealing with common factors, we want to look at each of our terms, so in this case the 3x and the 12, and find something that divides into both of them, or all of them if you've got more than two. To remove common factors, you really just got to remember that it's division. So we're going to divide each term by whatever our common factor is. Great. So looking at 3x and 12, we can't take out any variables. We only have an x in one term, so there's nothing common on that side of things. But if you look at 3 and 12, hopefully you'll recognize that we can take a 3 out from both of those. So the way we write that is we're going to pull out the 3, and then if we just divide each of those terms, 3x divided by 3 is just going to be x, the 3's cancel out, and 12 divided by 3 is going to get me 4. So there, we've removed a common factor. That's done. If we make it a little bit more complicated and say do a trinomial instead of a binomial, and look at 12x squared minus 18x plus 24. So again, when you're dealing with common factors, look at your coefficients, those are the numbers, and then look at your variables. So for 12, 18, and 24, there's a few different options for things we can take out, so you might notice that they're all divisible by 2 or 3, but in this case we always want to try to take out the biggest thing we can. So we're going to be able to take out a 6 here. As far as the variables go, we've got x squared and we've got x, but this third term just is 24. It doesn't have an x in it, so we can't take out any x's because it's not common to everything. So all we can take out is the 6 in this case. If we do that, 12 divided by 6 gets us 2, 18 divided by 6 gets us 3, but it's going to be negative 3, and 24 divided by 6 gets us 4. If we see something like 8x squared minus 4, hopefully you can look at that and say, okay, well, 8 and 4, they're both divisible by 4. The reason I wanted to look at this one is that it is something that people tend to mess up sometimes. If we're going to take out the 4 here, remember you're dividing. So 8 divided by 4 gets you 2. That part's fine. But if you do 4 divided by 4, it doesn't disappear. It's not 0. 4 divided by 4 is 1. So that should be 2x squared minus 1, not just 2x squared. You never lose terms when you take out common factors. If we look at this second one here, there's something else I want to point out, which is the fact that that first term, which we call the leading term because it's at the lead, has a negative on it. And we actually don't like that. So typically when you're dealing with polynomials, especially when you're dealing with common factors, if your leading term, your term at your front, has a negative in it, you're going to want to take that negative out. So in this case, our common factor is going to be a negative, and then 4, 24, and 52 are all going to give us a 4. From there, we just get x squared. And then 24 divided by negative 4 is now going to be negative 6x. And then negative 52 divided by negative 4 is going to be positive 13. So that's dealing with numbers, but what if there are variables? For example, something like 24x cubed y squared z plus 15x squared y cubed z to the power of 4 minus 30x y to the power of 4. So like I said, you want to treat each thing individually. So if we look at this, start with the coefficients. 24, 15, and 30. Those are all divisible by 3. So we're going to take out a 3. Then we go through the variables one at a time. So for the x's, we've got x cubed, we've got x squared, and we've got x. So if we want to take out some x's, we can't take out more than any of these terms has. So we can't take out x cubed as a common factor because only one of these terms has 3 x's to give. So you can only ever take out the lowest amount that any term has. In this particular case, that's going to be just 1x. Then we look at the y's. So we've got y squared, we've got y cubed, and we've got y to the power of 4. So the lowest amount of any of those is going to be a y squared. And then for the z's, we've got z to the power of 4, but the third term actually doesn't actually have a z. So there's nothing over here, so we can't take out any of those. So there's our common factor. It's 3xy squared. And now we just see what's left. So 24 divided by 3 gets us 8. X cubed divided by x. So let's talk exponent laws for a second. So I'm just going to slide over to the right here. Just a refresher from Math 9. If you do something like x to the power of 8 divided by x to the power of 5. So if you're dividing out variables, remember the exponent law for that is subtraction. So that's going to be x to the power of 8 minus 5, which would just be x to the power of 3. So when we're doing common factors, that is what we're doing. We are dividing. So in this case, for example, we had 3 x's in that first term. We're dividing by x, so we're just taking out one of them, which leaves us with x squared. We had y squared, but we took out y squared, so the y's are gone, and then we've still got that z that we couldn't do anything with. Second term, 15 divided by 3 gets me 5. X squared divided by x is just going to get me x. And y cubed divided by y squared is going to get me y. And then that z to the power of 4 is still there. Great. Go ahead and try to do the last term for yourself. So pause me if you need to, or just do it really quickly right now. And see if you can take out that common factor. All right. So running through it, 30 divided by 3 gets us 10, but it should be negative 10 because we haven't affected any negatives. The x is just gone. We had 1x, we took it out. Y to the power of 4 divided by y squared is going to get me just y squared, and there was never a z there in the first place. So that's what we've got. All right, looking at a few slightly more specific cases. What about fractions? So if I gave you something like 3x to the power of 4 over 5 minus 2 over 5. General rule of thumb when you're dealing with fractions, especially when it comes to factoring, is you kind of treat the numerator and the denominator as just two totally separate things. So on the bottom of this fraction, in our denominators, well, they're both 5. They're actually already common. So that is your common thing. You're going to take out a 5, but it's got to stay in the denominator. So it was down there, it stays down there. Up top, if you look at 3x to the power of 4 and 2, well, 3 and 2 you can't take out anything. X to the power of 4 can't take out anything. So there's actually nothing coming out from there. But we do want something on top of our fraction, so what we can do is just take out a 1. It's not going to affect anything, but it fills the space. Once we've done that, what we've got left is just that 3x to the power of 4 minus 2 that we weren't able to do anything with. The denominator is just gone. We took it out. All right. So looking at a slightly harder one, if we have 3x squared over 2 minus 9x over 4. So at first glance, this one's totally fine to work with, but the denominators don't match, which you could still take something out. But to make this look really nice once we're done, what we actually want to do is start by getting a common denominator, as if you were going to actually add or subtract these things. So if you look at those for 2 and for 4, your common denominator is just going to be 4. So we want to multiply that first fraction by 2 so we can make those denominators match up. That's going to get me 6x squared over 4 minus 9x over 4, which puts us in the same spot the last question was, where we now have a common denominator. But there's a little bit more we can do up top on this one. So give this one a shot on your own. Remember to take stuff out from the top and the bottom, take out everything you can, and see what you come up with. So pause here if you haven't already, and give it a shot, and then come back. So looking at our denominators, they match, which means we're going to be able to take out that common denominator of 4. All it is that's going to be down there. Up top, unlike the last one, we can actually do something this time. So from the 6 and the 9, we're going to be able to take out a 3, and then from the x squared and the x, we're going to be able to take out an x. So our common factor this time is now 3x over 4. Then if we see what's left, from the top of the first fraction, the 6 is now just going to be a 2, and we're down to a single x. And then for the second fraction, the 9 is now going to be 3, and the x is gone. Which leaves us here. And then last thing for common factors. If we had something like, say, negative 0.25 x squared minus 3.75. The thing with decimals, typically when we have decimals, if we want to take out common factors, we're just going to take out the entire first decimal, often, not always. So in this case, we're going to be taking out that 0.25 as our common factor. And remember, you can just do this with a calculator. You're just dividing. So for the first term, the 0.25 is just gone. It's just x squared. If you do grab a calculator and you do 3.75 divided by 0.25, you'll find that you get 15. And so there we go. We've dealt with the denominator, or the decimal rather, and that's when it's done. So that's common factors. But most of the factoring that you're going to deal with in this course is going to be the slightly more complicated factoring of trinomials, which you might remember last year is where you break up a trinomial into 2 individual binomials. So the second half of this video is going to focus on the easier kind of that, and then the second factoring video that you might also see on the channel is going to focus on the harder version of that, as well as some more individual special cases. So let's take a look at what we've got. If, for example, I wanted to factor something like x squared plus 3x plus 2. So thinking back to last year, you might remember that to factor something like this, you want to find a couple of things. You need 2 numbers, and those 2 numbers need to do 2 specific things. They need to multiply to one thing and add to another. Just as a quick refresher from chapter 3, remember this is basically standard form, so ax squared plus bx plus c. So that's kind of our generic thing. I'll refer to it a little bit here. So the first thing we want our 2 numbers to do is they need to multiply to c. So for us, c is going to be this 2 down here at the end. The other thing we need our numbers to do is to add to b, right, which for us is 3. So you run through your list of factors. There's not very many things that multiply to 2. Really, there's only one option in this case. You're going to want to get to a point in this course where you can do most of this work mentally, but for now, let's break it down a little bit. So if we're multiplying to 2, really that's just going to be 1 and 2, because 1 plus 2 does equal 3. Since there's no a value on this one, it's just x squared, this is the easier kind of factoring, and we can actually just take those 2 numbers and call it quits. So our x squared plus 3x plus 2 is going to break up into 2 factors, x plus one thing and x plus another thing. And those 2 things are just the 2 factors that we found. So it's going to be x plus 1 and x plus 2. So those just come straight from here. And this one's done. looking at a second one, x squared plus 6x plus 8. So we break it down again. We want to find two numbers that multiply to c, which in this case is 8, and add to b, which in this case is 6. There's slightly more options now, still not very many. Multiplying to 8, you've either got 1 and 8 or 2 and 4. And so if you think of those two pairs, well, 1 plus 8 is going to get you 9. That's no good. But 2 plus 4 gets you 6. And that's what you want. So it's that second pair of numbers that we like. So all we have to do is take those two factors, 2 and 4, the two things that multiplied to 8, and fill them in, and we're done. So our x squared plus 6x plus 8 is now going to be just x plus 2 times x plus 4. And so this will get a little bit more difficult as you throw in negatives or numbers that aren't quite as familiar to you as 8 and 6 and 4 and 2. But the process isn't going to change a whole lot for these more basic ones. So if we try x squared minus 8x plus 15. So something to keep in mind, always pay attention to your negatives. In this case, we want to multiply to our c value, which is positive 15. But we want to add to our b value, which is negative 8. So you got to keep in mind your integers. If you're multiplying to a positive number, your options are either a positive times a positive or a negative times a negative. In this case, we're multiplying to a positive 15, but we're adding to negative 8, which means we need negative numbers. Right? If you get positive numbers, you're never going to add to a negative. So if we're multiplying to 15, that's 1 and 15, or it's 3 and 5, but they're all going to be negative factors. So those first two are going to add to negative 16. The second two are going to add to negative 8. Those are the ones we want. And so our answer is going to be, instead of x plus and x plus 3 and x plus 5, it'll be x minus 3 and x minus 5. The more likely to mess you up kind are the ones where c is negative, because then you got to pay a little bit more attention to what you're doing. It's easy to get close to an answer but veer off onto a wrong tangent here. So if you want to multiply to negative 4, and in this case add to positive 3. So think back, if you're multiplying to a negative, the only way to do that is one positive and one negative. But now you got to be really careful to think, okay, well, which one's which? So let's think of what multiplies to negative 4 for a second. It's going to be 1 and 4, but it might be negative 1 and positive 4, or it might be positive 1 and negative 4. And then your last option is 2 and negative 2. So if we want to add to negative 3, negative 1 and 4 is the one that we want, because positive 1 and negative 4 would get us negative 3, and then those 2's are just going to get us 0. So the easiest way to think of it is, if you're adding to a positive, you're going to need more positives, so our larger number should be positive. If that had been negative 3 instead, then we would want to have more negatives, which means we'd want the positive 1 and the negative 4. Otherwise, we are good to go with what we've got. So we've got x minus 1 and x plus 4. And you can always check your answers by just foiling things back out, multiply it to see if you ended up where you started. All right, I'm going to give you a couple of these to try out on your own. So get these copied down, pause the video, factor them as best you can, and see where you end up. So pause here and give it a shot. All right, so for that first one on the left, this is one that does mess people up sometimes, because you see the 5 and the 6. And if you're not paying attention, you might go down the path of thinking 5 and 1 or thinking 2 and 3. So you got to pay attention to what you're adding to versus what you're multiplying to. In this case, if we want to multiply to 6 and add to 5, that's going to be 2 and 3. So this is x plus 2 and x plus 3. And really, you want to get to the point where you can do this question in that much space and time, where you just look at it and you know what you're dealing with. The second one here is a little bit trickier, and you might have messed up the numbers on this one if you weren't paying attention. So in this case, we want to multiply to negative 24 and add to negative 10. Oops. So 24 has got a slightly bigger number of factors, so that's going to be 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Thinking back to what I said on the previous example with the negatives, in this case we are multiplying to a negative and adding to a negative. That means we need one positive and one negative, and since we're adding to a negative number, our bigger number should be negative here. So in all of those pairs, we can just say the bigger number should be a negative number. If we add those all together, the only one that's going to get us negative 10 isn't the 4 and the 6, which might be what you thought at first. It's actually going to be the 2 and the negative 12, because 4 and negative 6 is going to get you negative 2. So you really got to pay attention to what you're adding. 4 and 6 will get you 10 if you're adding two positives or two negatives, but it's not going to get you a 10 with one of each. So since we've settled on 2 and negative 12, we've got x plus 2 and x minus 12, and we're all good. All right, one more. One thing we haven't seen yet is, well, what happens if there is an a value? And I did mention that that's mostly going to be part of the other factoring review video, but there is some questions where we can kind of get around that. So if you look at 2x squared plus 12x plus 10, if you look at all three of your terms, you might notice that they all have something in common, which is that they have a common factor. So something that really should have been a part of all of the previous examples, but wasn't because it wasn't relevant to those ones, is that you really should always start your factoring by checking for common factors every single time. Because if you can take out a common factor, you can make the question much easier. So 2x squared plus 12x plus 10, we are going to take out that common factor of 2, the same way that we did at the start of this video. And that's going to leave us with x squared plus 6x plus 5. And then that we're just going to factor normally, right? There's no longer an a value on that particular polynomial, so we can just run through it real quick. So multiplying to 5, adding to 6, there's really only one thing that does multiply to 5. It's 5 and 1, and that does get us 6. So this is going to get us 2 times x without the square, x plus 5, and x plus 1. Don't lose your 2. Don't lose your common factor. It stays out front. We're going to need that for doing other things, both in this unit and later on. So that is the first factoring review video. If you're still a little lost, like I said, dip back into the pre-calc 10 videos, take a look at how the factoring was done there, where it was broken down hopefully in more detail, and then go ahead and take a look at the next one where we see more complicated questions where there are a values that we can't remove, or where there's some special kinds of polynomials that we factor in slightly different ways.